Welcome to DC and AC Machinery. I will be your professor, Nadine Alex Bravo. So, energy can neither be created nor destroyed, and we know this as the law of conservation of energy, which tells us that energy is already there. Energy already exists in the nature, in our environment. All we have to do is be able to extract this energy. So we can only change the forms of this energy using appropriate energy conversion processes, but not in the sense that we're able to create them out of raw materials or scratch. Okay? Because in this raw materials or scratch, energy is already present. So, ang gagawin lang natin is to extract it and then we convert it so that we can use it. After being able to use it, we do not necessarily destroy this energy upon usage because still, after usage, energy will still be present. Okay? So, an interesting aspect about the energy in the electrical form is that it is neither it is so available directly from nature, nor it is required to be finally consumed in that form. So, it's not, we cannot find except one particular natural source of electrical energy, and that would be lightning. Pero aside from lightning, we cannot anymore find any natural resource na electrical energy or electrical inform na agad yung energy natin. Okay, so it's not directly readily available from nature. I-extract mo siya from one form and then you're going to convert it para maging electrical energy siya. Okay, pero although it's not readily or directly available from nature, hindi rin naman required na i-consume mo si electrical energy or yung energy in the electrical form. Kasi parang ang hirap naman na i-consume mo yung electrical energy. Kumbaga parang ikaw raramdamin mo, di ba? In a form of energy, raramdamin mo sa electrical, makukuryente ka nun. What we do is, di ba, for example, from mechanical work or from mechanical form, kino-convert natin yung energy papuntang electrical. Okay? And then after electrical, halimbawa sa residence natin, padadaanin natin yung electrical energy to supply lights until we're able to consume it as light energy. Diba? Yun yung ginagamit natin. O kaya naman, dun sa mga AC air conditioning units natin or dun sa mga fans natin, we are able to consume electrical energy in the form of mechanical ulit. So it's not necessary for us to consume electrical energy as in electricity, 'di ba? Kasi baka mamatay tayo doon. Pero we're not required to consume it in the electrical form. Instead, we convert it back to different kinds or different forms of energy that is more suitable for our need. Okay, pero gamit na gamit siya. Why? Because electrical energy is a popular form of energy because it can be transported. Okay? This is one of the most important forms of energy because siya lang yung makakapag-transport or siya lang yung pwede nating siya lang yung mobile, siya yung pwede nating i-store and then we can transport it or deliver it and then convert it back again para magamit natin siya. Unlike other forms of energy, hindi natin sila basta-basta pwede patakbuhin or padaanin or i-transport from one location to another. And that's why electrical energy is very important for us kasi it makes other forms of energy ready for our use. Okay? So, it's important that we understand electrical energy. So, as an introduction for DC and AC machines, we have to understand what magnetism and electromagnetism are because these are the major concepts or principles that are being used in the energy conversion process with respect to DC and AC machines. So, with that, we start this discussion with magnetism. So, with magnetism, we have to understand what magnets are, the objects that are able to provide magnetism. Okay, so magnets are objects. Okay, these are objects that can attract certain materials like iron, nickel, cobalt, and steel. And I know for sure, based on your experiences, marami sa atin may understanding na or nakahawak na once in our life ng magnets, di ba? It's in our toys, or we've used it in projects, and we have basic knowledge on magnets based on how we use them. Alam natin na it can attract certain materials. It can attract, it's not able to attract some materials. We also understand na may mga parts yung magnets natin na hindi nagdidikit, 'di ba? When we put the magnets close enough, hindi sila magdikit, that it feels like there's a particular harang, 'di ba? Parang may dimension sa pagitan nung dalawang magnets natin na hindi sila magdikit-dikit. Pero meron din namang side yung magnets natin na pag nilapit mo lang ng konti, biglang magdidikit na agad. And sometimes it's hard to pull them apart. Okay? Ito yung mga experiences na natin. And from these experiences, or from the definition in this presentation, it's already stated here that it can only attract certain materials. At itong mga materials na na-attract ng ating magnets, we call them ferromagnetic materials. And these ferromagnetic materials, they have ferromagnetism. Okay? Ferromagnetism is the ability of the ability of certain materials to be magnetized. So later on we'll be able to explain, okay, this ferromagnetism. So third important characteristic of magnetism is that, or of magnets, is that they are dipoles. When we say dipoles, let's compare this to our electric charges. Okay, so ang pinakamadaling comparison of magnets is with electric charge. So with electric charge, we know that this electric charge are monopoles. They are isolated poles. Because with electric charges, particularly with the two most commonly discussed particles when it comes to basic electrical engineering, we have positive and negative charges. Diba? Positive and negative charges. These are isolated poles. One particle is just positive and then the other particle is just negative. But with magnets, these are considered dipoles because one magnet will always have two polarities. With electric charges, magkahiwalay yan. This one is a positive polarity, this one is a negative polarity or a negative pole. While if you have a magnet, laging magkasama yon. Okay? You have a north and a south pole. In such instances that if you try to cut a magnet, kung sinubukan mo tong hatiin sa gitna, if you try to cut this in the middle, okay, this will result to two magnets which are not north and south, diba? You will not get one north and one south, just like you have one positive and one negative particle. But instead, you will have this as two magnets with two polarities, north-south din. Kaya siya tinawag na dipole. So, kahit anong cut mo dun sa magnet, lagi siyang merong isang north, lagi siyang merong isang south pole. Kaya tinawag natin siyang dipoles. Okay? So, unlike electric charges, isolated poles ito. Pag kinat mo, although it's impossible, or hindi naman impossible, it's hard to split these particles. Kasi yung atom pa nga lang, di ba? Yung atom pa lang, like for example, may mga specific, ano tawag dito tayo? May mga specific elements tayo na kapag kinat mo yung atoms nila, okay, or you try to break down into particles its atoms, it will give off huge amount of energy. Diba? So, mahirap. Ngayon, the idea of being able to cut one particle of charge, that's nearly impossible. But if you try to cut it, you will still result with two pieces which are positive and positive charges. Unlike this one, pag dipole siya, pag kinat mo, dalawa pa rin yung polarity niya. Okay. Next is, the direction of the magnetic field lines are from the north pole to the south pole. So, if you're going to draw here, ganito daw yung itsura no magnetic field lines. Okay, andito yung arrow. Kumbaga parang nanggagaling, parang yung outward field mo nanggagaling dun sa north side, papunta dun sa south polarity. With electric charges naman, ang meron tayo dito is, you have a negative charge which has outwards electric field line. So, outward ito. Okay. Tapos, you have your positive charges, your protons, with inward electric field lines. So, ito papasok naman. Kaya mangyayari dito if they get attracted to each other, yung negative charge mo, yung electric field line niya, magte-terminate siya dun sa ating positive charge. So, parang mayayari, ito yung condition or instance or situation wherein they are attracted to each other kasi nag-terminate si negative pole or negative charge papunta dun sa positive charge natin. Pero with magnets, so ibig sabihin parang yung parang ang mangyayari dito is magko-connect to dito, creating more electric field lines or a greater electric field. Pero with magnets, on its own, meron na siya agad magnetic field kung tawagin natin. Magnetic field surrounding the magnet itself. Okay, so around this magnetic field, okay, so itong magnetic field na to, parang pinupuno yan ng magnetic field lines, which, wherein this lines goes from the north to the south polarity or south direction. If you've had an experiment with physics, kagaya ng sinabi ko with our previous discussion, okay, when I met you last week Tuesday, meron tayong experiment sa physics wherein you will be asked to bring a magnet and then papahiramin kayo sa laboratory ng iron filings. Yun yung small particles, parang anong tawag doon? Parang buhangin, ganun. Or medyo mas malalaki na nakalagay sa Leyden jar. Okay, tapos Leyden jar ba? Tapos papakuhanin kayo ng particles yun, parang buhangin yun, tapos ipapaspread yun sa inyo around the magnet. And then, if you wait for some time, ma-observe mo na itong mga iron filings na to, itong parang mga buhangin na to, it will form a pattern around the magnet in the same representation of the magnetic field. Ganito din yung itsura niya. Okay? O kaya naman, pwede kayong gumamit ng magnetic compass. Tapos, i-try nyong i-position yung magnetic compass dun sa palibot ng magnet natin. Tapos, yung magnetic compass na yan, syempre, papalo yung arrow, yung pointer niya, papalo yun. So, ang gagawin nyo lang is to trace the direction of the arrow or the pointer. Tapos, pag minarkahan mo yun, makikreate mo din ito, makikreate mo din tong same representation of the magnetic field lines. As a whole, creates your magnetic field. So, ito, para kumbaga, hindi lang siya parang theoretical, it is actually true. Diba? Because of the experiments, pinapakita sa atin na ganun talaga yung itsura ng magnetic field lines natin or yung magnetic field natin. Okay? So, sabi dito, magnets comes in different shapes. It can be a bar magnet, okay? A horseshoe magnet. The horseshoe magnet is the most popular representation of a magnet, diba? Lagi siyang ginagamit. Ano ba yung horseshoe? Ito yun, no? Ito yung horseshoe magnet natin. Na yung horseshoe magnet, malalaman mo kung alin ang north and south pole dyan because of a white dot. Meron dyang white dot. Okay, may isang side dyan na may white dot. So, kung alin man yung white side na may white dot, yun yung north pole natin. Tapos, syempre, yung kabila, yun yung south natin, ano. And it can be a disc. So, I think siguro yung disc yung pinaka-familiar sa inyo, lalo na kapag, with your experience, kung ano yung nahawakan nyo na. Lalo na kapag bumibili kayo ng ref magnets, di ba yung nasa likod niya, yun yung bilog na magnet natin. Yun yung disc magnets natin. And with disc magnets, parang it's either yung taas or yung baba po yung north or south pole nyo. Okay, so yung isang face dito ay north and then yung ilalim niya would be south pole. Okay. So, there are two kinds of magnets. You have permanent magnets and then the other one is temporary magnet. So, ano yung difference? Pag sinabi mo pong permanent yung magnet mo, ibig sabihin, they do not lose their magnetic field over time. Kumbaga, iwan mo yung magnet dyan, or pabayaan mo, magnet pa rin siya, hindi nawawala yung magnetism property niya or yung ability niya to magnetize. Pero with temporary magnets, these can be magnetized by weak magnetic field, but eventually, nawawala din yung ability nila to magnetize kapag inalis mo yung source of magnet talaga. One example to this is, your magnets, like for example, meron kang bar magnet dito, tapos yung bar magnet mo, this one, normally your bar magnets or your magnets, these are permanent, yung magnets talaga, these are permanent magnets. Okay, you have a permanent magnet. Tapos si permanent magnet, dinikit mo sa pako. Okay? So, yung pako mo, iron siya. Gawa siya sa iron. Okay? Ma-attract siya dun sa magnet natin. Tapos, if you try to, kung susubukan mong idikit, itong setup na to dun pa sa ibang pako, di ba may mga pako na ma-attract dito. Tapos mapapansin mo, may mga pako na na-attract sa pako din mismo. Okay? In that sense, magiging temporary magnets yung mga pako natin. Okay? Because, with a source of permanent magnet, na ma-magnetize sila, and since they are ferromagnetic materials, they will be magnetized. At the same time, they will be able to magnetize as well because of the presence of a permanent magnet. So, itong pakong ito, this one, it's able to attract another nail, okay? And in that sense, it becomes a temporary magnet. Why temporary? Because, kapag tinanggal mo itong permanent magnet na to, pag tinanggal mo yung magnet mo, magkakalas-kalas ngayon yung mga pako natin. They are not anymore attracted to each other. So, ibig sabihin, they eventually lose their property or ability to magnetize when the source is removed. Ito ngayon yung tinatawag mo na temporary magnets. They can be magnetized, they can be attracted by magnets, or in a way, they can attract other ferromagnetic materials then, given that a permanent magnet or a magnetic field is present. Pero on their own, kahit ferromagnetic material siya, its purpose is not, kumaga parang, it does not serve as a magnet. Okay? Hindi siya ginawa para maging magnet siya. Pero pwede siyang ma-attract ng magnets natin. So, ang tawag natin doon, temporary magnets po yun. Okay? So, going back, pag sinabi mong permanent magnets, ang most common examples natin for permanent magnets is, number 1, lodestone. Okay? Yung lodestone po ang nag-iisang natural magnet natin. Okay? Ang problema is this lodestones have weak magnetic fields. Mahina lang yung magnetizing property nila. Pero yun yung, this is the only one, ano tawag dito? Natural source natin ng magnet. The other ones, these are all man-made magnets. So, you have here, this one is an alnico. Okay? An aluminum nickel cobalt alloy. Okay? So, nickel, cobalt are your ferromagnetic materials. And then, your aluminum is used para, yun, maging alloy siya. So, mabuo siya. So, this is an alnico. Alnicos are, paano ba? More expensive. Kumaga, parang, normally, the cheapest one would be ceramic or ferrites. Ito yun. Ferrites, when we call them, these are made from ceramics. So, ceramic magnets are the cheapest, kumbaga. These are the cheapest magnets that we have, but they are strong. They are strong magnets. But, if you have an alnico, this is more expensive, but a stronger type of magnet. And then, the strongest one would be this one, the third one, which is a neodymium. Okay, this is man-made also. So, neodymium is the most expensive, but the strongest magnet, the strongest permanent magnet that we have. Kasi, sabi doon, parang if you just have a half-inch diameter ng isang neodymium, kaya niya nang magbuhat ng several pounds of ferromagnetic material. So, imagine, yung half-inch diameter, kaya niyang bumuhat ng several pounds of material. Samantalang, if you have ferrite, ceramics, and alnico, for example, parang few iron nails lang yung pwede niyang i-pick up, diba? Or paper clips, diba? Pero si neodymium, several pounds agad yung kaya niyang buhatin. Okay? So, papaalala ko lang hindi lahat ng pako pwede nating i-magnetize. Depende sa material na ginagamit. Or depende sa material kung saan gawa yung pako natin. Kasi, may mga pako tayo minsan gawa sa stainless steel. Halimbawa, yung ating mga, yung ating mga screws, diba? Minsan stainless steel sila. So, hindi sila ma-attract ng magnets natin. Okay. Number 2 is your temporary magnet. So, yun nga, yung temporary magnets natin, na-explain na natin yun kanina. Pero ang question dito is, paano ba tayo gumagawa ng magnets? Okay, so there are several ways wherein we can create magnets. And number 1 to that is, with a considerable amount of time, we can expose our ferromagnetic material na siya, we can expose our ferromagnetic material to a magnetic field until it becomes influenced, kumbaga, or parang malink papunta sa kanya yung magnetic field nung source of magnetic field natin or yung source ng permanent magnet natin. So, if around the magnetic field of a permanent magnet, kumbaga parang at a considerable amount of time, hinayaan mong or inexpose natin yung ferromagnetic material natin doon, eventually it can become a magnet, but it will take a lot of time. Para mapabilis yon, we can stroke the metal with a magnet. Kumbaga parang papandayin mo yung metal, pero ang gamit mong pampanday, magnet din. Kaya lang ang problema minsan, depende on the strength of stroking, pwedeng masira yung permanent magnet natin, diba? So, kung meron man, the most common way on how we create magnets is we expose the magnets to the magnetic field and heat. Okay? And then, isa-stroke natin siya habang pinapalamig natin siya. So, in that way, yon magiging permanent magnet din siya. So, those are the ways on how we do it. Okay, you can search for it online if you're very interested on how these magnets are created. Pero, when these magnets are created, sabi nga natin, we are introducing heat kasi meron tayong certain materials wherein, if you reach a specific temperature, they become ferromagnetic. Kaso, may maximum temperature yon. At yung maximum temperature na yon, we call that the Curie temperature or the Curie point. When we say Curie point, ito yung point wherein, kapag inabot mo yung temperature na yon, mawawala yung ferromagnetic property ng metals natin. Okay? Kaya, when we expose metals, para maging magnet sila, when we expose them to heat, for them to become magnets, kailangan bantayan natin yung Curie point ng certain material na yon, para naman, sa halip na, baka kasi mamaya sa halip na maging magnet siya, lalo pang hindi siya maging magnet. Kasi nga, nawala na yung kanyang ferromagnetic material, kaka-expose mo sa kanya sa heat. So, kaya natin siya ina-expose sa heat because there's a certain temperature wherein na-activate natin yung ferromagnetic property ng isang klase ng metal natin. Okay, so, that's how you create your magnets. And then, let's talk about permeability. So, in electromagnetism, permeability is the measure of the resistance of a material against the formation of a magnetic field. Or, in magnetism naman, permeability, magnetic permeability naman, is one of the magnetic characteristics which indicates how easily magnetic material is being magnetized. So, ibig sabihin, kung magnetism ang pag-uusapan natin, magnetism is the ability to be magnetized. Okay? Permeability in magnetism is the ability to be magnetized. So, ibig sabihin, if your magnet has high permeability, ibig sabihin, malaki yung chance na mamamagnetize natin siya. So, ang quantity symbol po natin for permeability is mu. Okay? Ang unit natin for permeability is metric. That's Henry per meter. Okay? Henry per meter. Or, it can be Newton per squared ampere. So, you have two kinds of units that we can use. Okay. Next is relative permeability. So, relative permeability is the ratio of the permeability of a specific medium to the permeability of free space. Ibig sabihin, you have a medium, you have a specific material, meron siyang sariling permeability, that's your mu, yun yung diniscuss natin kanina. But normally, when we talk about permeability, we always talk about permeability in terms of relative permeability. Ibig sabihin, kinukumpara natin lagi yung permeability ng specific material dun sa permeability ng surrounding environment niya. And most likely, the surrounding environment would always be a free space or kung tawagin natin is a vacuum. Okay, so doon natin ikinukumpara kasi with permeability, ang hirap namang magsaulo pa ng powers of tens or scientific value of permeability. Kaya normally, kino-compare na lang natin siya so that in terms of multiples na lang yung values na tatandaan natin if ever may kailangan tayong tandaan. So, if relative permeability is simply equivalent to mu divided by mu sub O, because we are comparing the medium with the free space, para malaman natin yung specific permeability of a medium, then if the relative permeability is the value that is available, we simply multiply that to the absolute value or to the absolute permeability or the permeability of your free space, and there you will have it, the the permeability of the specific medium that you have. Kasi nga, normally what we have is relative permeability. Ito yung information na readily available para sa atin. So, if relative permeability is a comparison of the permeability of the medium with the permeability of free space or the surrounding environment, then, kung gusto mong malaman yung scientific value ng permeability ng isang material, we simply multiply mu sub O to mu R, and then you'll have mu be equivalent to mu O times mu R. Okay? So, mu sub O is the permeability of free space again with a value of 4 pi times 10 to the negative 7 Henry per meter. Okay? Relative permeability, since mu is Henry per meter, and then your permeability of free space is also Henry per meter. Ibig sabihin, magka-cancel out lang to. Therefore, your relative permeability is unitless. Kasi ratio siya eh. Therefore, yung unit ng mu mo is Henry per meter pa din or Newton per squared ampere. Okay? So, obviously, relative permeability of vacuum with reference to itself is unity. Hence, for free space, the absolute permeability is 4 pi times 10 to the negative 7 Henry per meter. Kung ang gagamitin mong magnetic material ay ang free space din, so halimbawa, ang mu mo or ang medium mo, mu of the medium is free space with a value of 4 pi times 10 to the negative 7 Henry per meter. Pag kinuha mo yung relative permeability ng isang free space, ibig sabihin, your medium is free space, and then you're going to compare this to the surrounding environment, which is free space also. Ibig sabihin, you're simply comparing it to itself. So, mangyayari, relative permeability natin for free space would be 1. Okay? Next. Na tayo sa law of magnetic force. So, Coulomb was the first to determine experimentally the quantitative expression for magnetic force between isolated point poles. So, if you're going to, although we know that magnets are dipoles, the link between magnetism and electricity or electrostatic is because of Hans Christian Ørsted. So, he was the first one to realize that there's a relationship between magnets and electricity. Kasi in a certain experiment daw during his class, parang he has a circuit, meron siyang circuit. The circuit is supplied by an electric energy. So let's say may load siya dito. Ibig sabihin yung circuit mo may kuryenteng nagfo-flow dyan. Pero every time, kumbaga parang he was trying to demonstrate the direction of the flow of electricity. Pero every time he was trying to put a magnetic compass, so this is a magnetic compass, he was trying to put this, every time he's trying to put the magnetic compass close to the circuit, napapansin niya na nagde-deflect yung magnetic compass natin. So, kumbaga parang naumiibo siya. So, that's the point that he realized there's a certain link or relationship between magnets and electricity. And because of that, since Coulomb was the first one to establish a relationship between isolated poles, diba sa electrostatic, we have a fundamental of electrostatics like, na ang sinasabi ton, like charges repel, if you can still recall, like charges repel, and unlike charges attract. Okay? But since Hans Christian Ørsted was the first one to identify that there's a link between electricity and magnets, then nirelate natin with magnetism yung inaral ni Coulomb. And that's your fundamental law of electrostatics, which is, yun nga, opposite poles attract then with magnets, and then same poles repel with magnets. Then, so ibig sabihin, if you have a north and a south, like a positive and negative charge, they will attract each other. But if you have same polarity, like north-north or south-south, ito yung sinasabi ko kanina na, if you have two materials, 'di ba? If you have two magnets na experience natin nung bata tayo na merong side dun yung magnets natin na hindi siya mag-attract. And then when you're trying to put them together, hindi siya magdikit, not unless you force it, pero parang pag pinapwersa mo siya, if your hands are light, mararamdaman mo na parang may dimension sa pagitan, 'di ba? That's the magnetic field. Na yung magnetic field lines na 'yon, nakaganyan. Kasi 'di ba ito, nakaganito to. Ito yung line of attraction. Samantalang ito dito sa kabila. So para mangyayari, itong north na to, hindi siya magte-terminate dun sa kabilang north. Kasi they are not attracted. So mangyayari, itong magnetic field lines na to, nagbabanggaan. Okay, nagbabanggaan yung magnetic field lines. At yung magnetic field lines, since nagbabanggaan sila, yun yung rason kung bakit parang feeling natin may dimension sa pagitan ng dalawang magnets natin, okay? You have to understand that these magnetic field lines, they do not intersect. Okay, they cannot intersect. And you can prove that using the experiment I mentioned kanina, yung experiment na ginagamit para ma-identify mo yung direction ng magnetic field lines, doon mo mapapansin na wala kang linya doon. Although there are several lines here that goes from north to south, there are several lines that goes north to south, hindi mo makikita yung same line na yung dalawang lines na nag-intersect sa isa't isa. Lagi silang may spaces, kumbaga. Okay, they do not intersect. Okay, so that's why when they do not intersect and they do not terminate with each other north to north, magkakaroon ka ng dimension sa pagitan nila. Okay, so normally yung ilang properties natin with electrostatic, almost similar than with magnetism. Most likely, specifically, si magnetic force, sabi dito, the magnitude of force daw, so same with electrostatics, may force of attraction, and may force of repulsion din. Depende sa kung yung material ba na i-attract or i-repel natin ay nakapasok dun sa magnetic field ng permanent magnet natin. So, the magnitude daw, if ever nandun siya sa loob, ibig sabihin there are two situations. Pwede siyang ma-attract, pwede siyang ma-repel. So, yung attraction and repulsion, pwede natin siyang i-quantify with a force. So, ang sabi dito, the magnitude of force of attraction or repulsion between two magnetic poles is directly proportional sa product ng kanilang pole strengths, okay, and inversely proportional to the square of the distance between them. If you're going to compare this with electrostatics, meron tayong tinatawag na Coulomb's law. Okay? Si Coulomb's law, sinasabi niya na yung force of attraction daw or repulsion between two isolated poles is directly proportional to the product of their charges, the product of the charges of each isolated pole. So, alam natin yung symbol natin for charge, di ba? Q yun. So, you have Q1, Q2. And inversely proportional to the distance between the charges, which is D squared. Inversely proportional to the square of the distance between the charges. So, D squared yun. Ngayon, kung mapapansin mo dito sa formula dito, yung force daw between two magnetic objects, okay, is directly proportional to their pole strengths. At itong pole strength na to, which is represented by phi. This is phi, okay, capital or uppercase letter phi. This is referred to as your magnetic flux, okay. Your magnetic flux means it is the pole strength, yung lakas, pole strength, ng ating mga magnetic poles, okay. The pole strength of the magnetic poles is quantified using the magnetic lines. Yung magnetic lines natin, yung linya mismo sa magnet natin, those are called magnetic flux. And together, this magnetic flux is known also to be the pole strength, yung lakas ng magnetism around the magnets that you have. So, kagaya dun sa isolated poles mo, yung strength ng isolated pole mo, we call that charges. At itong charges na to nakabase din to sa electric field lines. Same with magnetic poles. These magnetic poles have pole strengths, okay? And these pole strengths are quantified using the magnetic field lines naman. So, kung mapapansin nyo, okay, meron ka ditong square of the distance din, similar to electrostatics, diba? The force of attraction or repulsion between electric poles. So, meron kang D square din dito. Pero meron ditong mu, diba? Which we know as permeability. And sabi nga natin kanina, permeability is the ability to be attracted, diba? Pero kung i-review nyo ulit si Coulomb's law has a formula which is equivalent to KQ1, Q2 over D squared. Ito, this is the statement of the law. Meron tayong proportionality relationship dito or proportionality symbol. And alam natin, for us to be able to use the proportionality symbol, kailangan natin siyang palitan ng constant para maging equation siya so that we can use it. So dito, meron tayong tinatawag na Coulomb's constant K. Coulomb's constant K. At itong Coulomb's constant na to, this is equivalent to 1 all over 4 pi permittivity, E sub O. Okay? Okay? So, yung 1 over 4 pi E sub O natin, kung mapapansin nyo, di ba yung value ng mu dito? Let me get a note first. Okay, para lang mapakita ko. Di ba meron tayong F is equivalent to K, Q1, Q2, all over D squared. Kung magnetism pag-uusapan natin, meron tayong flux 1, flux 2, sorry. Directly proportional. Meron tayong flux 1, flux 2, all over mu R squared. Di ba alam natin that mu will be replaced, if you're solving for mu, it will be replaced by mu O, mu R. Okay? R squared. Okay? Na yung value ng mu sub O mo, mapapansin mo that is 4 pi times 10 to the negative 7, di ba? Mu R squared. And dito naman sa electrostatics natin, sa Coulomb's law natin, ang K nito, di ba? K here is equivalent to 1 all over 4 pi EO, or absolute permittivity, times Q1, Q2 all over D squared. So, mapapansin mo dito, itong permittivity na to, ito yung pwedeng equivalent na permeability natin. You also have your 4 pi, same dito. Okay, and you also have square of the distance. And then you have strengths of the charges as in charge. And then you have your pole strengths as in magnetic flux. Okay, tas mapapansin mo pa, in the formula, na kapag sinolve mo daw si the force between magnets, that's actually equivalent to K, flux 1, flux 2, all over mu, R squared. Na yung K na yun is actually equivalent to 1 all over 4 pi pa. Which is still different from mu sub O. Kasi, ito pong E sub O na to, is, E sub O is from, anong tawag dito? Permittivity, which is equivalent to EO-ER din. Okay. Where EO has a specific value din. Pero collectively, itong K na to, that's equivalent to 9 times 10 to the 9 Newton meter squared per Coulomb squared. So, dito, kino-compare lang natin na almost similar din yung formula nila. Magkakaiba lang yung constants na ginagamit. At symbols, of course. So, yung relationship exists with the formulas. Kitang-kita mo na that they are almost similar, diba? That electricity is almost similar to magnetism. Okay, so going back, okay, if F is equivalent to K, flux 1, flux 2 all over mu R squared, let's note the units. So, for magnetic force, you have the magnetic flux in Weber for metric system, the distance is in meter, and permeability is in Henry per meter. Altogether, you will still have an amount for force, and we know that the standard unit for force in MKS is Newton. Okay, so ang formula natin for force is simply K flux 1 flux 2 all over mu R squared, where K is equivalent to 1 all over 4 pi, and mu is equivalent to mu O, mu sub R. Okay? Let's move to magnetic field strength. Okay? Pag sinabi naman natin magnetic field strength at any point within a magnetic field is numerically equal to the force experienced by a pole of 1 Weber placed at that point. Okay? Parang, sa electrostatics kasi, meron tayong tinatawag na electric field intensity or electric field strength. Let me write that down here. Meron tayong tinatawag na electric field intensity, or we also call this as electric field strength. Okay? As the strength, okay. As the title itself, or as the description says, field intensity to or field strength. 'Di ba yung magnet, yung electric charge mo, meron siyang electric field lines. The electric field lines are quantified in terms of charge as a charge. And this electric field lines, if together creates an electric field, at para malaman mo kung gaano kalakas naman yung electric field, yung surrounding nung iyong electric charge, we call that electric field intensity. The charge itself, or the numbers of electric field lines that it has, we call that charge, pero yung lakas nung nung electric field na binubuo ng charge natin, we call that electric field intensity. Ganon din po sa magnets. So, yung magnet natin, meron siyang magnetic field, di ba? Meron siyang magnetic field lines. Itong magnetic field lines na to, we call that magnetic flux. Okay? Altogether, we call that pole strength, yung magnetic flux ng magnet natin. Pero kung pag-uusapan natin is yung, kasi dun sa magnetic flux or pole strength, ang pinag-uusapan natin dun, magnet. Dito, ang pag-uusapan natin yung magnetic field. Okay? Magnetic field. Kasi alam natin na yung lakas ng magnetic field, may relationship siya with distance as per discussed dito. Pag malayo yung object, okay? Kung ito yung center, andito yung magnet mo. Pag andito yung ferromagnetic material mo, medyo malayo siya. Ibig sabihin, yung lakas ng magnetic field dun sa point na yun, iba, dun sa magnetic, yung lakas ng magnetic field dito kapag malapit ka dun sa object mo, dun sa magnet mo. Okay, so para malaman daw natin yung characteristic ng isang magnetic field, we compute that using magnetic field strength. And for you to be able to solve for the magnetic field strength, our quantity symbol for magnetic field strength is H. At ang formula niya is F all over flux. Okay? Ang idea po dyan is, para malaman mo, balik tayo sa electrostatics, para malaman mo kung gaano kalakas yung isang electric field, ang ginagawa natin dyan is, nag-i-introduce tayo ng test charge. So, kukuha ko, this is a charge already, diba? This is a charge already. Meron siyang magnetic field. Kukuha ko ng isa pang charge. Tapos, normally, yung charge na yun, this is already equivalent to 1 coulomb charge. Yun yung standard na ginagamit natin. Tapos, yung 1 coulomb charge na yun, ipopwesto ko siya dito. I will try to position it at a point in the magnetic field. And then, I will try to quantify gaano kalakas ba yung force na na-experience ng test charge ko. Okay, so in short, electric field intensity is simply just force. Kasi inaalam lang natin gaano kalakas yung puwersa na nararamdaman ng test charge. Kaya nga lang, of course, the amount of charge that we experience changes or varies depending on the amount of charge of the test charge we are using. Kaya nga, ini-standardize natin na yung test charge na ginagamit ay 1 coulomb. Para naka-standard yung unit ng magnetic field strength as per coulomb lamang. So, kung gusto mong malaman magkano yung force na ma-experience ng different kinds of charges, na hindi lang 1 coulomb, we simply multiply that to magnetic field strength kasi, to electric field strength kasi, ang formula po ng electric field strength, this is simply the force experience between the two charges divided by the charge which is used as your test charge, divided by QT. Eh, di ba ang formula natin for F, that's KQ1, Q2 all over D squared. And to elaborate this, alam natin ito yung two charges na pinag-i-interact natin sa isa't isa. At ito yun. Diba? Ito yung dalawang charges na yun. Ka-quantify natin yung force na experience silang dalawa. Ito yung formula na yun. KQ1, Q2 over D squared. Divide that by, we're going to divide this by, alin ba sa dalawang ito ang ginamit mong test charge? So, obviously, ang ginagamit nating test charge, yung charge with 1 coulomb charge. So, pipiliin mo lang. Halimbawa, ito yung Q1 mo, tapos si Q2 yung naging test charge mo, ibig sabihin, divided by Q sub 2. So, maka-cancel lang to. Ang mangyayari, magre-result yung electric field intensity formula mo as KQ1 over D squared. So, para malaman mo at a specific distance from the isolated pole, para malaman mo ano yung ma-experience na force kada coulomb ng isang charge dun sa point na yun. Ito yung formula na gagamitin natin. And obviously, ang unit na to would be Newton per coulomb, di ba? Kasi force divided by charge. So, Newton per coulomb siya. Ngayon, kung gagamit ka ng ibang charge dun sa pwesto na yun, multiply mo na lang siya with gaano ba kalaki yung charge na pinwesto mo dun sa point na yon, makakancel yung coulombs na yun, then you'll be able to get the force it will be able to experience. So, ini-standardize lang natin in such a way, inaalam natin at specific points in the magnetic field, inaalam natin gaano kalakas yung puwersa na mararamdaman ng mga charges. Same with magnetic field. So, kagaya dito sa illustration dito, parang gagamitin natin yung isang pole as a test pole. Okay? Ilalapit natin siya dun sa isang magnetic field na tinetest natin. So, kumbaga, ito yung magnetic field na tinetest natin. And then, we're going to use a test pole para malaman natin ano yung puwersang mararamdaman ng pole na to kapag pinosisyon ko siya dun sa specific distance from the magnet or from the permanent magnet na meron ako. And for us to quantify that, so, pag nilagay mo siya doon, ang makakwenta natin doon is the amount of magnetic force every Weber or every flux of magnets we place in that position. Kaya mangyayari dito is, you will have H, your magnetic field strength, okay, be equivalent to the magnetic force between the two poles, wherein one pole is your test magnet, divided by yun, kung gaano ba kalakas in flux, gaano ba kalaki yung magnetic flux nung test pole mo, which is in Weber. Kaya magiging unit ng magnetic flux, magnetic field strength natin would be Newton per Weber, or collectively, it could be known as Oersted or ampere per meter. Okay, so dito, ang kina-quantify lang natin is gaano kalakas yung magnetic field in terms of per unit of Weber na ilalagay mo doon as a test charge. Okay, next property that we have to understand is, so with magnetic field strength daw, it is very helpful to understand na marami tayong terms na ginagamit to refer to magnetic field strength, which is capital letter H. So among those are magnetizing force, field strength, magnetic intensity, and intensity of the magnetic field. Okay, baka kasi mamaya mapagkamalan nyo si magnetizing force to be permeability. Hindi po, although we know that permeability is your ability to magnetize. Baka mamaya maisip mo na magnetizing force yun. So hindi ha, kasi force na yung pinag-uusapan dito, pero not necessarily magnetic force. So pag magnetic force, that would be your force between two magnets. Pero pag magnetizing force yun, that's magnetic field strength. Ibig sabihin, yung field ang pinag-uusapan natin. Okay? Moving forward, you have magnetic flux. Okay? The number of magnetic lines. So, nasabi ko na to kanina, di ba? Nung diniscuss natin si magnetic force or the forces between magnets. So, magnetic flux refers to the number of magnetic lines of forces set up in the magnetic pole. So, ang quantity symbol again natin for the magnetic lines of forces or magnetic flux is phi, uppercase phi. Ang unit symbol niya is Weber with symbol of WB for the MKS system. And then for Gaussian, that's Maxwell. Ang unit symbol natin dyan would be Max. And then for English unit, that would be lines. So, ang unit symbol natin, lines pa rin. So, important conversion factors are, ang isang Weber daw po of magnetic flux is simply equivalent to 10 to the 8 Maxwell. Okay? And then, 1 Max is also equivalent to 1 line. So, syempre, pag sinabi natin magnetic flux, magnetic lines ito. So, kung ilan yung lines na to, kung ilan yung lines na yan, okay, yun. Yun yung English unit natin. So, kung gaano man karami yung lines na yan, ganun din kalaki yung Maxwell natin in CGS. Kung gusto mo siyang i-convert papuntang MKS system, ito yung gagamitin nating conversion factor. Okay, so, it's safe to say that 1 Weber will be equivalent to 10 to the 8 Maxwell, will be equivalent to 10 to the 8 lines then, because Maxwells are equal to lines. Okay? Okay, next. Doon tayo sa flux density. Okay? So, flux density is given by the flux passing per unit area through a plane at right angles to flux. So, tawag dito. Di ba meron tayong, kilala natin si mass density. Okay, dito natin i-relate. Si mass density, this is an amount of matter that is present in a specific space. Kaya ang formula natin with mass density, that's rho, mass over volume. Mass refers to amount of matter. Gaano karaming amount of matter ang pwede natin pagkasyahin to a specific space. Okay? At yung space na yon, that's 3-dimensional. Kaya nga volume yung gamit natin dito. Pero with flux density kasi, with principle of energy conversion, ang pinag-uusapan natin dito is flux cutting. Para makapag-convert tayo ng magnetic field, okay, or fluxes. Para yung fluxes natin, ma-convert natin papuntang electrical energy or a form of energy which is electrical, kailangan yung magnetic field lines na yun, maputol natin or makat natin or ma-interrupt natin. So, if you have an existing, for the purpose of study, buong magnet to. So, pinaghiwalay lang para lang ma-identify na we are talking about two different poles. Pero itong poles na to, dalawa yung, itong poles na to, or itong magnets na to, dalawa yung poles nila. Pero ang i-consider lang natin yung tigisang pole ng dalawang magnets. Pero buo yan ha. May south ka dito, and then you have north dito. Pero ang pinag-focusan natin is, you have two separate magnets. In between these two separate magnets, since magkaiba yung polarity nila, therefore, pwedeng mag-terminate yung magnetic field lines nung north papunta dun sa south, nung kabilang magnet natin. Ngayon, ang idea with energy conversion is, kailangan ma-interrupt, okay, kailangan ma-interrupt itong mga magnetic field lines na to para makakreate tayo ng electrical energy. Okay? Meron tayong, pag nag-aral tayo ng mga machines, meron tayong mga machines na kung saan stationary yung magnet nila. Okay? So, ito yung magnet mo. This is your magnet. Meron siyang magnetic field line dyan. Yung i-interrupt nating magnetic field, ito. Yung magnetic field ng isang magnet lang. So, mangyayari doon, may paiikutin tayong object around the magnet. Okay? Pero ito, you have two separate magnets. Tapos, yung magnetic field line sa pagitan nila, yun yung i-interrupt natin. So, mangyayari, nandito sa gitna yung, halimbawa, rotating object man yun, or vertically moving object para lang maabala or ma-interrupt natin yung magnetic field lines, or kumbaga, makat natin yung magnetic field lines na yun. So, when we cut this magnetic field lines, alam natin this magnetic field lines, although they have space, pero not necessarily important para sa atin yung height ng magnetic field lines. Kasi linya yun, hindi naman natin makakwenta yung height na yun. So, most likely, pag pinag-usapan natin yung flux density, yung pag-uusapan natin dito, two-dimensional space, wherein, yung two-dimensional space na yun, halimbawa, ito yung object na gagamitin mo para makat yung magnetic field lines mo. Gusto lang nating malaman, gaano karaming fluxes yung tatama dun sa area nung space na ginagamit natin to interrupt the magnetic fluxes. So, gano'n man karaming lines yung makakat or papasok dun sa space na yun yung tinatawag natin na flux density. Gano'n karaming magnetic fluxes ang kayang mag-ipon-ipon to a specific space, okay, or magnetic field lines to a specific space, yun yung flux density natin. Kaya naman, your symbol for flux density is B. Okay? And that would be equivalent to the amount of magnetic flux between two poles divided by the area of the space we use to interrupt, okay, to interrupt this magnetic field line. So, by symbol, that would be Weber per squared meter kasi ito flux to. So, that would be Weber per squared meter. And collectively, we call that Tesla. So, 1 Weber per squared meter, that's equivalent to 1 Tesla. And Tesla has a unit of capital letter T. For Gaussian naman, di ba, ito ay magnetic flux, so that would be Maxwell all over, since CGS to squared cm ngayon. So, Maxwell per squared cm, that's equivalent to Gauss naman. Okay, and then, for English, you have lines per squared inches naman. So, lines for the magnetic flux divided by, for English unit of area, that's squared inches. So, lines per squared inches siya, wala siyang equivalent. Okay. So, yun, that's flux density. So, ito kasi mga bagay na to, this is important in understanding how we will be able to convert, kasi pag-uusapan natin to pagdating natin electromagnetism, these are the terms you have to understand para maintindihan natin kung paano, para magkaintindihan tayo pag diniscuss natin kung paano tayo nagko-convert ng magnetism papuntang electricity. Okay? So, if we want to summarize all the units that we have, okay, we can create a table here para lang alam natin that you have quantity symbol, diba naman, and then units, so with MKS, CGS, and then English. So our first quantity would be flux, halimbawa. Let's say you have flux. Okay? Ang symbol natin for flux is Phi. Okay? Ang MKS unit for flux is Weber. Symbol natin is WB. Ang CGS unit natin is Maxwell. Ang symbol natin is Max. And then, ang English unit natin is lines. Ang symbol natin, lines pa rin. And then, you have magnetic field strength. Magnetic field strength. Ang symbol natin with magnetic field strength is H. Diba? Ang unit natin with magnetic field strength is Weber per meter. Newton per Weber. or there are other references or mga lumang references natin, gumagamit sila ng symbol for magnetic field strength na ampere turn per Weber. Okay, kasi if you can recall, di ba, meron tayong unit ng permeability na naka-ampere. Okay. In CGS, Gilbert per centimeter. Gilbert per centimeter or Oersted. Okay, ang symbol natin for Oersted is OE. And then for English, we do not use a unit for English, a magnetic field strength. And then we have flux, area, siguro. Symbol natin for area is simply A. So, ang metric natin dyan is M squared, cm squared, and squared inches. For flux density, our symbol for this is B. Diba? So, that's flux over area. So, you'll have Weber per squared meter. And that would be equivalent to Tesla. Okay, that's capital letter T. And then you have, for CGS, you have Maxwell per squared cm. This is equivalent to Gauss. Okay. And then for English, you have lines per squared inches. Okay. So basically, yun yung mga kailangan natin tandaan. With permeability, you have a symbol of mu. Diba? We have mu, we have mu r, we have mu sub o. So, ang unit natin dito would be Henry per meter. For relative permeability, this is unitless. And then for absolute permeability, this is 4 pi. This is constant times 10 to the negative 7 Henry per meter. So, these are the important terms that we have to understand along with their units. Okay? So, continuing this, these are the important personalities with magnetism. So, the first one is Joseph Henry. He discovered the electromagnetic phenomenon of self-inductance. We'll be able to understand self-inductance pagdating natin ng electromagnetism. Okay? So, he also discovered mutual inductance independently of Michael Faraday. Though Faraday was the first to make the discovery and publish his results. Lahat ng ito, maintindihan natin when we go to electromagnetism. Henry developed the electromagnet into a practical device. He invented a precursor to the electric doorbell, specifically a bell that could be rung at a distance via the electric wire in 1831 and the electric relay in 1835. So the SI unit of inductance, the Henry, is named in his honor. So ibig sabihin pala yung permeability natin, yung Henry doon, that means that's inductance. Okay. Henry's work on the electromagnetic relay was the basis of the practical electrical telegraph, which was invented by Samuel F.B. Morse, a Morse code, and Sir Charles Wheatstone, separately, the Wheatstone bridge, yung circuit na ginagamit natin in electronics. Okay. We also have Wilhelm Edward Weber. He is a German physicist, and together with Carl Friedrich Gauss, they are the inventor of the first electromagnetic telegraph. So, obviously, sa kanya pinangalan yung unit, yung SI unit natin for magnetic flux, di ba? Okay. Nikola Tesla is a Serbian-American inventor, electrical engineer, mechanical engineer, physicist, and futurist, who is best known for his contributions to the design of the modern alternating current or AC electricity supply system. So, if you can still recall yung mga kwento ko nung basic electrical natin, di ba sabi natin that DC, energy before was DC, wala pang AC. And alam natin DC is not able to move at a very long distance. Hindi siya long range mobility. Kaya, because of Nikola Tesla, he was able to discover AC. And with AC circuit, with the fundamentals on AC, we're able to develop it into AC circuits until we're able to transport electrical energy from several miles, di ba? Kasi before, ang energy pag tinatransport, talagang metro-metro lang yung pagitan ng mga poste, tapos naka-battery pa. Okay, kasi nga DC eh. So that is Nikola Tesla. And in honor of Nikola Tesla, yung flux density natin, yung SI unit natin na Tesla, okay, which is Weber per square meter, it's named after Nikola Tesla. Okay. And then, si Johann Carl Friedrich Gauss, yung kasamahan ni Wilhelm Edward Weber. So, he is a German mathematician who contributed significantly to many fields, including number theory, algebra, statistics, analysis, differential geometry, geodesy, geophysics, mechanics, electrostatics, astronomy, matrix theory, and optics. So, with Johann Carl Friedrich Gauss, he is an embodiment that mathematics is indeed needed in sciences for us to be able to understand, model the equations, and then analyze the theory existing and make it into a fact. Okay. We have Hans Christian Ørsted. So, as I've mentioned kanina, siya yung unang-unang nakapansin that there's a relationship between magnetism and electricity. Although, some of the formulas that are used with the relationship between magnets and electricity are not discovered firsthand by Hans Christian Ørsted. Kasi nung mapansin niya na may relationship si magnetism at si electricity, it's in 1800s, 1820? Okay, I think it's in 1820s. Wherein before that, na-discover na yung charges, di ba? At saka yung relationship between charges by Coulomb. So, he is a Danish physicist and chemist who discovered that electric currents create magnetic fields, which was the first connection found between electricity and magnetism. And actually, yung discovery niya was one of the most revolutionary discoveries along with the discoveries of Isaac Newton, di ba? Okay. Along with the discoveries of James Clerk Maxwell. Okay, so he is a Scottish scientist in the field of mathematical physics. His most notable achievement was to formulate the classical theory of electromagnetic radiation, bringing together for the first time electricity, magnetism, and light. Okay? As different manifestations of the same phenomenon. So, ito naman, si James Clerk Maxwell naman, siya naman yung parang nag-summarize, na parang naisip niya na, pare-pares lang pala to, mga phenomenon na to. So, yung light daw, electricity, and magnetism, these are similar, almost similar phenomenon kasi yung mga formulas na ginagamit ay halos magkakaparehas. So, yung relationships halos magkakaparehas lang. So, Maxwell's equations for electromagnetism have been called the second great unification in physics. So, parang na-summarize nga niya, na-consolidate niya. Hindi, sa halip na parang magkakahiwalay na inaaral, he was able to consolidate until the relationships on each phenomena was discovered. Okay, along with after the first one realized by Isaac Newton. Okay. So, yun. There you have it. A basic or fundamental idea on magnetism. Our next video to this would be electromagnetism, wherein you will be able to understand how these magnets are used to create electricity.